This is a graphical problem. It tells us that there's a graph F, which is shown. It's continuous. It consists of two line segments and a portion of a quarter circle. It also gives us a point on the graph we're going to use later. Okay, first thing they tell us is that they tell us the definite integral from -6 to 5. I know we don't see -6 on this graph, is 7, but they want us to find the value of this definite integral. So you're thinking, how can I get from here to here somehow? So one of the properties that we learned is that if I connect the two functions in the middle, it'll be equal to the total of the beginning bound and the end bound. So the idea is if I go from -6 to -2, but then somehow I want to get this 5, and if I add it to -2 to 5, this, right, it connects at this -2, so this is the same as going from -6 to 5. So this is the property that we want to use. And the idea is I have some of these pieces. So -6 to -2 is what we're looking for. That we need to find. -2 to 5, we're going to go ahead and get from the graph, and I'll do that in a minute. And then this value here, -6 to 5, was given as 7. So let's go ahead and find this piece right here. So that's really just asking for the area underneath the graph from -2 all the way to 5. Okay, now one thing you'll notice is, do you see the first two little triangles? This one up here, this one down here, they have the same area, but one's above the x-axis, one's below, so those two values will cancel out. It doesn't matter what it is, so I don't need to count those. Now I gotta count the rest of this. Okay, so I'm gonna break it up into little pieces. So let's start with this little piece right here. Again, I'm looking for the definite integral, so you're going to have to count it as negative if it's below the x-axis. So this piece right here, it's a triangle, so it's 1/2. The base is 1/2, the height is 1, and this is going to be 1/4. And I want to count it as negative because it's below the x-axis. The next piece that I see is this piece right here. That's above the x-axis, so I want to count it as positive. But again, it's a triangle, so it's 1/2. The base is 1.5, right, from here to here. The height is 3. So if you punch that out, this is 1/2 times 3/2 times 3 is really 9/4. So there's that green region. And then the last piece that I need is I need this region right here. But this is not a geometric figure, it's a curve. So the only way to come up with that piece is to actually think about it like this. The area of that square right there, it's a 3 by 3 square, so that's 9. And then I can subtract off this portion of the graph, and that will give me that purple region. But this blue portion right here, notice, is a quarter circle. So it's pi r squared divided by 4. R happens to be 3. So this piece is 9 pi over 4. So that's this region right here. This is that purple graph. And the way I did it is I did the area of the square and then subtracted off the quarter circle. And so now all of this would be 9/4 minus 1/4 plus this. 9/4 minus 1/4 is 8/4, which is 2. And then I also have the 9 minus 9 pi over 4. So this I got geometrically. This is what I'm trying to figure out. So this definite integral they wanted me to find would really be 7 minus all of this. And I'm going to just leave it like this and put it in parentheses, whatever that value is. Okay, next step, they want us to evaluate this definite integral again. But notice I've got a couple things going on. Notice you're adding, you've got a number in front. So this is where I want to use the property to go ahead and split up. So I'm going to go ahead and pull this 2 out in the front, and the 4 gets added separately, so I'm going to go ahead and break it up into this. So that's my first step. This piece right here, we do not have an equation for f prime, but what's the antiderivative of f prime? It's just f. So what do? Plug in the upper bound, subtract off the lower bound, plus this, we can go ahead and take the antiderivative. Antiderivative 4 is just 4x, and we're going to integrate that, evaluate it from 3 to 5. Now this is given, if I look at the graph, what is f of 5? That's just the point on the graph, which is 0. So this is 0. I don't need to write that. F of 3 is, this is the point that we want to use. They tell us that point is 3 minus square root of 5. So it's really negative 3 minus square root. So I'm going to distribute that negative so it becomes a plus. This would be 20 minus 12. And then if you go ahead and simplify all this and combine like terms, I've got a negative 6 plus 8. So this is going to be 2 plus 2 square root of 5. Okay, next. They tell us there's another function called g, which is the integral of f of t from negative 2 to x. They want absolute maximum. So what's the first step? We need to find critical numbers. So I need absolute maximum of g. So I need to find the derivative of g and set equal to 0, or does not exist, but there's no, does not exist here. But the graph that you're given is the graph of f, but we know that g prime is really the same as f of x. So where is the graph of f that's given is equal to 0? Well, let's look. I'm going to erase all this. The only place where it's equal to 0 is here at negative 1, and here, which is exactly 1/2. But we're looking for a maximum. This, notice the graph goes from negative to positive, so it's a minimum. So really, this is your only possibility for a maximum. So x equals negative 1 is the only critical number I need to check. And then what else do we check? We always check endpoints, which are negative 2 and 5. And then for absolute, we take these and plug it back into the original. So remember, we need at all of these values, actually, I'm going to do it like these. I need to plug it back into the original. So I need g of negative 1, g of negative 2, and g of 5. And the biggest number will give me my max. So let's start with g of negative 1. So I'm going to plug in negative 1 here. So that will be the integral of f of t from negative 2 to negative 1. And let's see what happens. From negative 2 to negative 1, notice, is this piece right here. So, and if you did that, you will get 1/2. Let me get rid of this. So this is going to give me 1/2. G of negative 2 is just going from negative 2 to negative 2, so we're not adding up anything, so this is 0. And then this is negative 2 to 5 of f of t. And then this part, we figured out up at the top, we figured out this was 11 minus 9 pi over 4. So remember, we did that by coming up with all these pieces up here. So you can use that answer. And then which number is the biggest? The biggest value is this value, so I would say the maximum occurs at, this is my maximum, right? They want the y value, so you can go ahead and type that in. Okay, lastly is a limit problem. So what do we do when we take limits? We're going to go ahead and just plug in the value, direct substitution. So 10 to the first minus 3 f prime 1, f of 1 minus arctangent of 1. Direct substitution. 10 minus 3, what's f prime of 1? F prime of 1 is the slope of this graph at x equals 1. This is just a straight line. I'm going up 2 over 1. So this would be 2. 1 minus f of 1 is just the y coordinate on the graph. F of 1 is just 1. And then the arctangent of 1. What's the angle that gives you a tangent of 1? That would be pi over 4. And then you could just leave your answer like